This is Software Engineering Radio, the podcast for professional developers on the web at SE-Radio.net. SE-Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello, this is Kishore Bhatia for Software Engineering Radio. Today's episode is about blockchain with Kieren-James-Lubin. Kieren is the co-founder of BlockApps, a PhD candidate at Berkeley, researching mathematical physics, interested in data science and blockchains. He's also on the technical working group at the Ethereum Enterprise Alliance. As an engineering lead at BlockApps, I work closely with Kieren. Welcome to Software Engineering Radio, Kieren.
Thanks for having me.
Today, we are going to talk about blockchains and specifically cover Ethereum blockchain protocol and smart contracts. So, Kieren, what is a blockchain in its most basic form?
It's an excellent question. In its most basic form, a blockchain is simply a record or a ledger, which is append-only, which records transactions of some kind. And these transactions could have a monetary implication, or they could be representing the advancement of a state of some sort of business process. And the unique feature that blockchains provide beyond traditional databases or pieces of paper that are append-only is that this ledger can be agreed upon by multiple counterparties without a central clearinghouse. So in comparison to our current system, in which we have many clearinghouses which exist more or less to establish the truth, blockchain technology in and of itself can establish the golden record of who is holding what when.
Interesting, yeah. So you mentioned distributed ledger here, and the fact that you can have a gold copy agreed upon by many parties. Would you dive in a little bit in that?
Certainly. So the first application of blockchain technology was Bitcoin, and it was sort of the origin of the idea, which has a larger implication, in my opinion. So what Bitcoin achieved was a fully peer-to-peer currency. And the important aspect of a currency, if we think about paying each other cash, is that cash is not really counterfeitable, and that when it changes hands, it really changes hands, which is easy to imagine in the physical world. But in the software world, we struggle to make digital content scarce in some sense. It's very easy to duplicate bits, and yet US dollars are not meant to be counterfeited. So what Bitcoin achieved is having a peer-to-peer digital currency using the underlying blockchain technology for the value transfer use case. So basically the way this manifests is that given that our transactions are in Bitcoin are going to be I send 10 Bitcoin to Kishore, the problem that needs resolving is, what if I also send 10 Bitcoin to someone else, and those are the only 10 Bitcoin that I have? How do we decide who actually gets the Bitcoin? And we previously believed that really only a centralized system could handle reconciling between those two transactions. They decide, which transaction occurred first, and that's the record. But Bitcoin actually has proven that through its consensus algorithm, that it's possible for a peer-to-peer network to decide, which transaction happened first and which one is the authentic one.
I see. Yeah, that's pretty interesting. You mentioned a couple of terms here around peer-to-peer, value transfer, digital representation of the currency, and the fact that these peers are actually running a consensus algorithm. We should dive in a bit on all of these, but to begin with, covering these topics, how do you describe achieving such a distributed consensus within a blockchain network?
Let me describe, I guess, the experience of joining a network like Bitcoin or Ethereum, and that might be helpful. So one downloads, a piece of software that people tend to call a client, like a blockchain client. In a sense, it's not a client-server architecture, but it's a client of the network, so to speak. And so one downloads this piece of software. And what the software does is basically download all of history after joining the peer-to-peer network. So the client will know a few entry points to the network, and can find peers through these entry points, and the peers will transfer the history of the system to the client that's maybe on my laptop, so that I can verify all the current, state of all the balances in the system. So that process occurs. I could, if I liked, start broadcasting transactions before I'm in sync, but it's better to know that I'm in sync with the network before I start doing that. And the way that the software can tell that the data is authentic is actually, in the case of the public Bitcoin network, due to the consensus algorithm known as mining, essentially. And so what mining is basically at each, they're called blocks, block and blockchain. At each block, which block consists of a bundle of transactions, say value transfer transactions, and some metadata. And the metadata is a reference to the parent block, which establishes the order of the system, and some data that sort of proves that the block required some computational expenditure to create. And this uses cryptographic hash functions. Basically, what the property of that metadata is that someone, burned compute on their laptop, on their GPU, in their data center to produce this block, and it has a unique kind of information theoretically unlikely fingerprint, which proves that they spent the money on it, and so that acts as sort of a truth mechanism and also a rate limiting mechanism for the open peer-to-peer network. So in practice, it takes on the Bitcoin network about a 10-minute interval to produce a block, and transactions are not confirmed until they appear in a valid block, and really you should wait a few blocks before you consider transactions confirmed. And so this mechanism allows a network with an arbitrary number of participants to establish the truth. And also, when I join it later, it's efficient to verify that this network is the truthful network because the most compute power has been spent on it. And that's a thing that you can check as you're downloading history. So that's a technical answer. But the key components are that the data itself is verifiable, and it's verifiable for a real-world expenditure, proving that the order of the system, the order of the blocks in the system and the data is authentic.
Gotcha. So if I understand correctly, we're talking about distributed system, pretty much decentralized, no central authority or a single system making a decision and controlling the source of truth. But every peer in that network has an exact copy of the number of transactions that have happened in a particular sequence, and that is deterministic, and you can get a complete view of the ledger. How is that actually achieved in a system where people can't just trust these machines running all over the world over internet? So I'm trying to dive into the trust aspect of it. How do you trust such a network?
Well, yes, there's a technical answer and a philosophical answer, I suppose. I think the technical answer is that what you can tell from the network is what people spent their money on in terms of the mining process. So it's sort of not majority vote. It's not it's not captured by a single counterparty, but rather it's vote by CPU essentially. So the people that spend the most energy and the most on hardware on deciding what the canonical history is are the ones that determine the truth. So those people are also incentivized to, and they're incentivized in terms of the issuance of the token. So Bitcoin, Ethereum, and their public form only issue new tokens essentially by this mining process. And so when you win a block, right, there's actually a reward that you can send to an address of your choice, likely one that you can control. And that functions as an incentive to align with the correctness of the blockchain network itself. And so those that are producing these blocks are, again, aligned with the sort of future of the protocol, so to speak. And so maybe that's the definition of trust correctness that we're talking about. So, in a traditional IT environment, trust is more of a PKI, certificate authority kind of perspective, that you know who everyone is and what they're doing, and there's sort of an audit log of everything that a particular person does. And this technology achieves similar ends, though through a different mechanism of having a trust-based or trustless, depending on your perspective, system, without needing to know all the individual identities.
I see. And for the listeners, PKI is public key infrastructure. Kieren, would you mind diving in a little bit in establishing that trust over these publicly exposed networks using certain, secure mechanisms like public keys, and the fact that someone putting information on such a decentralized system can actually, see some use cases, not just currency, but other information sharing use cases?
So from a technical perspective, joining this network, it's an open peer-to-peer network. And so you always have to be careful to lock down the appropriate ports. And, as you're opening ports to go connect to this peer-to-peer network, there is some concern about what kind of payload from a data perspective that could land on your machine. In the case of a Bitcoin or Ethereum, the wire protocol is pretty constrained, so that it's hard for anyone to send something that you're not expecting, and if you do, you certainly don't just execute it on your native machine. So less of a concern there. But it is an open internet protocol. The intent is that anyone can join the network, and 5,000-10,000 people will be active on each of the Bitcoin and Ethereum networks at a given instant. And you may not know who they are. They may be connecting with proxies, this, that, and the other. And that doesn't affect the security of the core ledger, in that it's not an individual trust-based system, but rather a sort of vote by CPU system.
So what has been and still is driving these notions and demands for decentralized systems?
Yeah, so I think there are sort of several movements that are going on. I think the expectation on behalf of on consumers is kind of going in two directions. One, consumers want sort of personalized technology. They want to own and manage their own data. They're more sort of personally centric. People don't want to go show up to their bank. They want to use some kind of online interface and then have it figure out what they want. So there's that one track, but also we're actually more comfortable with connecting to the world just through the internet, and less in person. And so somehow all of our data is moving to big companies like Google, Amazon, and whatnot, despite having a stronger individualistic desire to manage it. And so the technology in itself is a bit of an attack on the sort of centralized data clearinghouses that we have. You can find them anywhere. Most software applications are delivered in a client-server manner, and your data resides with some corporate. And so the philosophical roots of Bitcoin, which is the root of the blockchain technology itself, are definitely in a movement called crypto-anarchism, which I believe began, as early as the late 80s, early 90s. And, Bitcoin was one of the first large realized initiatives of the sort of cypherpunk crypto anarchist groups. And, what it is a currency that's not controlled by the government or that sort of thing. So that is kind of one of the philosophical origins of the technology. I would say in the United States, our financial systems work quite well. We can grumble a little bit, but they're not especially high cost, and they're fairly efficient. In certain other countries where you have hyperinflation or capital controls or this, that, and the other, the demand for cryptocurrency or digital currency is probably higher, in that people see it as a vehicle to protect their assets, their wealth, etc. And really, in the U.S. consumer experience, Bitcoin, Ethereum, whatnot are not all that prevalent. But in other countries, paying with Bitcoin is actually sort of extremely common. So, I think it's sort of indicative of a general movement towards individual-centric sovereignty experience of products, etc., that was rooted in sort of a somewhat extreme crypto-anarchist philosophy to start, but has sort of made its way into the mainstream in some form.
I see. So if I understand it right, the history and the roots of this movement and what also got created as a blockchain technology is a lot driven by individuals, people wanting control of their privacy, their data, and also the fact that the digital world, as we get more and more connected, would have all of that data available in these big data stores of banks and corporate vaults, and people want that control. You called crypto anarchism. Could you throw some more light on that history?
Yeah, so I'm certainly not an expert there for you listeners out there, but basically the movement, I think one of the key figures his name is Tim May. I think he wrote an original manifesto that, basically the idea is that we as people could interact mostly through machines. This means, everything from your day-to-day to corporate governance to currency to this, that, and the other. And further, in some sense, not have our traditional governance institutions in place, be they the federal government or institutions that we rely on to achieve what we need to achieve in the day-to-day, but rather that this could all be software that we individually can run, individually can control. So there's there is obviously an anarchist aspect to it. There's also a bit of a pie in the sky aspect to it as well. But, with Bitcoin, some of this has been in theory achieved. Now, whether it's sort of in practice achieved from a consumer convenience perspective, I would question. But I think that is the root, at least, of, so far as I know, of the people who were working on Bitcoin before its launch, who have never been officially identified. But the technology in itself has strong sort of philosophical roots that are well documented as being in part crypto-anarchist.
Is Bitcoin the only big example of how the blockchain revolution began? Or how would you establish the theory of blockchains in the real digital world outside of the cryptocurrency revolution?
Yeah, it's an interesting point. So I think Bitcoin first launched sometime in 2009, and it was sort of the sole blockchain and cryptocurrency for some period of time. It was open source, so people made many derivative versions of Bitcoin with sort of varied parameters, minor changes to the core so that there's something like 1,000 or more Bitcoin derivative currencies out there. So that happened sort of relatively quickly. To the next really major event, especially with respect to public blockchains, was the Ethereum white paper was written November 2013, I believe, by Vitalik Buterin. So at the time, an 18-year-old, wunderkind, if you will, who was very, very mathematically precocious. He was a student at the University of Waterloo, which is Canada's best technical university, and got so interested in Bitcoin, he also covered it from a journalistic perspective that he started quite actively working on projects in the Bitcoin space. Then found that these projects were difficult to execute on Bitcoin because basically the core protocol was very hard to extend, and people were building sort of bespoke single use case Bitcoin derivative blockchains and not leveraging a general purpose system in which one blockchain could have multiple applications. And so that was sort of the core idea of Ethereum. And so the Ethereum project, looking forward, the actual public blockchain launched, I believe, in July of 2015. And heading into that time, we also saw, huge growth in corporate interest in blockchains. Large banks, large oil and gas companies, large retailers, large manufacturers are now seeing that the problems that are solved in the public blockchain space are still present in a corporate context in which, there are many thousands, tens of thousands of parties within a supply chain, for instance, and they have a hard time deciding, a unique record of which goods were shipped to whom when, just as Bitcoin resolves the unique record of value transfers from whom at what time and which order. So the technology is growing in the public understanding of its applicability, and I think the definition also is expanding to really any system that is a peer-to-peer system of record in which participants can join later and verify the history and continue to participate on a go forward. I would call that a blockchain. So in my opinion, the public network is which has mining, for instance, as a consensus algorithm, is not the only use case or not the only definition of a blockchain.
This is really helpful. I think we definitely covered a lot of the converging concepts that gave an evolutionary concept like blockchain a big thrust, beginning with crypto anarchism, cryptocurrencies, trust, and the decentralized world. You mentioned a couple things, mostly around the use cases evolving now in the enterprise world outside of the cryptocurrency. We definitely want to dive more with Ethereum on that. But let's just first cover some of the main concepts that we want to actually understand of what comprises a blockchain network. What are the core technologies that one has to understand as a software engineer to start making sense of a blockchain network? What would you say are the some of the things that one would have to learn or have experience in order to interpret some of the things that create a blockchain?
Yeah, it's a good question, and it depends sort of at what level one is engaging. From an application developer perspective, one only really needs to understand kind of something about the core blockchain data model, and then some set of APIs to interact with it, to post new transactions, to read historical transactions, to load the state of the blockchain at the given point in time, etc. That is getting to be a fairly solved problem in that a pretty good web developer can build blockchain applications fairly easily right now. From an operational perspective, though, one has to sort of understand really networking technologies. So blockchains, again, they're peer-to-peer networks in which there's communication. The communication is usually the broadcast of particular transactions. So there's also an identity management aspect. Transactions in the blockchain world are sort of cryptographically signed messages from particular, public keys, essentially. So the only way in the Ethereum world and the Bitcoin world that value transfer occurs is that, again, a transaction, which is a cryptographically signed message, is appended to the ledger, and that is the definition of, value movement, so to speak. And so one has to have that understanding in one's, as one is planning one's IT infrastructure. And then, one has to think about how the management of those keys would occur. Are the keys with the participants? Are they in a server somewhere? Are they using secure hardware and whatnot? How's the network monitored? How are the particular nodes in the network, checked for health, checked for consistency, and so on? And this in a public network scenario, this is more something that you would check on your laptop. But for an enterprise use case, there are still quite heavy traditional enterprise IT requirements to participate in a blockchain network, which are somewhat different than traditional IT infrastructure requirements.
This podcast is supported by Atlantic.net, hosting solution provider of healthcare HIPAA, PCI compliance, and ad tech. If you're feeling the pain of having outdated technology, call Atlantic.net and get the latest security firewall, intrusion detection, backup, disaster recovery, and virtualization. Or if you're starting a new project or not getting the results you want from your current providers, Atlantic.net can help you succeed. With fully audited solutions and 23 years in business, they won't let you down. Visit Atlantic.net to learn more.
So just to recap, you mentioned based on the experience level and the area that you're involved in with blockchains, there's a lot going on with the experience in networking, peer-to-peer, messaging protocols. There's also identity management with the ability to understand cryptographic keys, encryption, decryption at the node level, at the individual level. There's this concept of databases or data stores that come in, mostly aligned to the distributed ledger aspect of the blockchains. And then the systems at scale for IT, where how do you actually, run and maintain and operate a large distributed system at scale. But that's really helpful. On the other hand, you mentioned Ethereum is basically picking up as one of the next frontiers for blockchains, mostly also diving into the enterprise aspect of it. Can you throw some more light on what is Ethereum, cover some of the basic foundational concepts there?
Certainly. So Ethereum is a technology and it's a protocol. One thing that's sort of maybe not broadly understood about Ethereum is that there's a spec and definition for this protocol. It's like HTTP. So anyone can go and implement a version of Ethereum if they so choose. So Ethereum is also a public blockchain. And so what that means is, as I described before, one can download a client, an Ethereum client, connect to a peer-to-peer network, download the history, and then start to broadcast transactions and validate the new transactions on a go-forward basis. So the unique feature of Ethereum against something like a Bitcoin or any of Bitcoin's derivatives is that it's a more computationally rich execution environment. So again, Bitcoin supports basically the use case of value transfer and a little bit more. You can embed metadata in transactions and sometimes interpret that metadata in the real world. And so that could describe some sort of derived asset rather than just a Bitcoin. It could be that a transaction means that some real world asset transfer of, say, a physical good even has happened, and that's about the limit. So what Ethereum adds are smart contracts, and the smart contracts basically achieve is the ability to model more complex workflows than you can with a technology like Bitcoin. So if you can imagine a complex business process like settlement of a security, for instance, is a popular use case in financial services. When we talk to some of our customers about how these settlement processes occur, they're not really very simple. They're long running. There's many steps, which can often be modeled as sort of a large multi-tenant state machine. And that's essentially kind of what Ethereum is. It's that many parties can interact with a smart contract or set of smart contracts, which represent the state of a business process, and at a sort of permissioned level can carry out that process to its conclusion, all on the same shared system of record.
Interesting. So Ethereum offers, if I understand correctly, a way to embed code with some levels of storage and a permanent contract on the chain, establishing a level of agreement between parties that are making that contract. Is that right? And can we dive into an example of that maybe in the supply chain world, as you mentioned earlier?
I would say that is accurate. The smart contracts don't necessarily have to represent a legal agreement. Really, they're software objects, but they can certainly represent a legal agreement. But then there's some question of, which is the truth, the legal agreement or the contract itself, which I think our societies have not quite resolved. But yes, certainly. So as an example, one of our production systems with a large mining company, and basically smart contract entities, there are many of them, but are basically representing kind of raw materials and their motion through the supply chain. So these raw materials are mined, then they're sent to one of potentially hundreds of vendors, which are sort of engineering companies which do analyses to these samples, and the provenance is very important. So it's a regulated process, and each action that's done to the sample is sort of a regulatory event in some sense. And so there are sort of PDFs that get produced that are kind of attached to the sample and sort of just as valuable as the sample itself. And what the blockchain is achieving is sort of creating a unique record of the provenance of the sample as it goes across many different corporations, and then is eventually ends its life, and it ends its life by being stored with the government. So in that case, the workflow is somewhat complex. The samples are first mined, or really they're first procured by a central office user, then they're mined, and then so that's a state advance. Then once they've been mined, they are ready to ship to a vendor, and the office selects which vendor to ship to. And then they're in transit, and then the vendor that can claim the samples, and only that vendor can claim the samples. That's actually checked at a cryptographic level. And so the samples are sort of imported, so to speak, as they've been received. Then that vendor can do analysis to them, which is involves the addition of some metadata to the sample's history. And then the vendor will either ship the sample to another vendor or ship it to be stored. So, somewhat complex business process there, and would be a difficult thing to do without this smart contract facility, which is kind of coordinating this complex workflow.
I see. Interesting how smart contracts have been used here. So what are these smart contracts developed in? Like, is there a specific language to develop them?
Yeah, that's a good question. So the standard today basically is a language in the Ethereum world. The language is called Solidity. And Solidity is sort of has JavaScript, C style syntax. And it is a compiled language, actually. It compiles down to the Ethereum bytecode. Ethereum is a virtual, sort of a stack-based virtual machine as its execution engine. And so the smart contracts are compiled to this language, and so it's a fairly easy thing to get up and running with. So if you look into Solidity, viewers out there or listeners out there, that you can kind of get started. Some of the positive features of Solidity versus a traditional programming language where that you might have encountered, there's always the question, why not write the smart contracts in a traditional programming language, is that Solidity ensures that transactions are deterministic. And so if you make a call to the system time in say a language like Go, Java, whatever, that won't necessarily have the same result at different physical locations in the world, on different computers, and so on. And so that starts to break some of the value proposition of blockchain technology. If you lose determinism, then all you have is an ordered set of transactions, and they may have different meanings to different people. So you really want this determinism property. And so Solidity is sort of a nice object-oriented language which has the determinism property. It's sort of like the smart contracts are more or less like small talk objects. Yeah.
And you mentioned Solidity is a good way to actually get started with writing smart contracts on Ethereum. That also differentiates Ethereum from the previous implementations like Bitcoin for a blockchain-based system. Can we dive in a little bit into what kind of tools or testing libraries are available for a developer to start writing smart contracts and testing them? We want to understand for our listeners how they can start with developing smart contracts.
Certainly. So there's a variety of open source tools available to start prototyping smart contracts. So If you just search for Solidity, you'll find lots of them. So also a plug for my company. So BlockApps, we distribute a developer edition of our software, which has JavaScript SDKs for Solidity. It's really aimed at the web developer, and so you can just download this. It requires Docker and nothing else. Comes up and running, and you can start uploading and interacting with Solidity contracts right away. There are also other tools. Truffle is a popular tool for prototyping smart contracts. And if you download any of the Ethereum code bases, there's a bit of configuration to do if you don't use our stuff, but you can start interacting with smart contracts from a testing perspective there. And what's usually done is setting up a test suite, likely in JavaScript, that deploys the smart contracts and then runs their particular functions and checks that the result is what you expect.
I see. That's pretty interesting. The use of the different tools and testing libraries would help the ecosystem evolve as well and get more and more developers excited about it. I will put in the links in the podcast notes for the white paper, the Solidity language, and also the tools Kieren mentioned in this talk. So Kieren, moving on to the areas and the problems that we are solving, what do you see in your company, in BlockApps specifically, as areas of focus that you are constantly evolving in and developing on?
Right, and for the listeners, maybe some context here would be useful. So, BlockApps is a B2B enterprise-focused company, and our mission is to take the core technology that blockchain represents, particularly in the Ethereum variant, and make it consumable for enterprises, sort of large and small. And so enterprises have different requirements, and many cannot engage with the public network, in part because of the level of control over it from a governance perspective, in part because of how visible the data on it is. And so we have taken really the exact same core technology, but added certain features that enterprises need to be able to derive some of the same benefits that the public network has. So our focus in terms of, say, customer base, but also, on a roadmap perspective, we're about 50% working with financial services customers and neighboring industries. We have some insurance and that sort of thing as well. And then sort of 50% of the rest. And the rest is leaning heavily into supply chain management use cases. Big oil and gas, mining, but also heavy manufacturing companies that have high value inventory, consumer packaged goods, in which showing the authenticity of the food we eat is a really important thing. Major retailers, etc., are all interested in logistics optimization and traceability, which is something that the technology can provide.
Interesting. You mentioned a couple use cases in supply chain, also the natural resources, energy, mining company example that you gave before. And then another good one around the food, the farm to table. Could you go in and provide an example for the farm to table provenance, and how blockchains can help there?
Certainly. So there's tremendous all-around interest in the farm-to-table provenance of goods, and the goods can be of any kind. One example is just food. Another example would be, say, in the U.S. we have export rules around which sort of technologies can be sold to other countries, especially in the defense industry. And so, a use case we've heard is that one really has to know if one is depending on any components that might have regulated export, basically, and that it's difficult in some cases to know if you're building a complex machine, maybe with hundreds of thousands, millions of parts, that all of them have the origin that you expect. And so there, the blockchain is used as a ledger for basically the whole supply chain, and all the participants in the supply chain have an identity on the blockchain. And so the life cycle of a good can, as it moves, as constituent components or assembled as physical components, it's to say raw materials to, somewhat processed materials to smaller packaged goods to larger goods. That whole history is present and auditable. And so the technology allows something that hasn't existed. Basically, previously, the systems of record of all the entities in the supply chain were not linked in any way. And so while there would be one good, one couldn't go back and figure out, all the hops that the constituent components had made in their lifetimes, so to speak.
I see.
The technology itself can establish that multi-corporate, multi-tenant golden record for what the good actually is.
Interesting. Yeah. And meanwhile, there are a lot of, blockchain use cases that are coming up to kind of compare it with the distributed databases and central data stores of the world that have already been established in some of the industries. What would you say for a lot of, the use cases that are being thrown at blockchains where they don't initially seem like or even are specific to blockchains? Is there a specific use case or mechanism that you have seen to validate some of these use cases?
Sure. There's a couple questions embedded there. One suggestion that I'd make is to not view the technology as a database replacement. While it is a data store and has database properties, it's not necessarily optimized for that particular use case. I think of blockchains more as a kind of coordination, workflow, data integration, and collaboration tool, so that blockchains are actually just a safe way for many parties to collaborate on a single source of record that can be transparently synchronized across those parties. And so you do get differentiated value with the technology really when there's more than one party. And that could mean in some cases there are multinationals that have different subsidiaries or branches, if you will, and those can behave as sort of different legal entities. So in some cases, even a single corporation can derive benefit from deploying the technology. But where the technology is really differentiated is when there are complex multi-corporate or sincerely multi-tenant business processes that suffer for not having a unique golden record. And one way to detect those use cases is to look for the presence of clearinghouses. So you have the financial services, the exchanges also have some clearing capacity. There's the Federal Reserve with ACH, there's the Depository Trust and Clearing Corporation and whatnot. And they're all looking at the technology because, in a sense, it achieves part of what their institutions achieve, which is to establish kind of the golden record of the truth of what belongs to whom. But you also see clearinghouses in other industries like airline, hotel, say hospitality bookings. Actually, it's very complex reconciliation processes that are powered by global distribution systems that again have more or less the same function. So that's a good guideline. If you see a clearinghouse, maybe there's a technology solution that would be sort of more participatory for the network that depends on that clearinghouse. And that's kind of where we have certainly some of our focus.
It's good to know that there are some clear use cases coming up specifically around asset tracking, supply chain. You mentioned farm to table, clearinghouses that have certain amount of, tracking and reconciliation to be done within, say, a multi-party network or, something where you want to build trust with a single source of truth. So this is, this moves us into the next point, mostly towards the end of the show around the challenges that you have seen or the evolution that is from here. So, you mentioned Ethereum kind of addressed some of the points, within the Bitcoin network and came up with this additional concept of smart contracts. Also, the use cases have been evolving as we speak. But what are some of the technology challenges that you have seen in this space? And then we move into the evolution of this beyond here.
I'd say that the technology is, compared to many others, relatively immature. But I would say that's not the main barrier of adoption. I think the difficulty in adoption, especially in the enterprise context, but even in the public network context, is that people have to change their behavior. And then in the enterprise context, to really see the benefit, they have to redesign to some degree how they do business. And that means having a more collaborative relationship with their partners, suppliers, customers, that, that's what it would really take to get a whole consortium or, network of participants with the same blockchain online. And so that's a very complex process. And then there's governance concerns as okay, so we're a consortium, but do we need a legal entity to check who everyone in the consortium is, even at the network permissioning level, at the corporate level, etc.? And who maintains the infrastructure? Do we all have to maintain the infrastructure, etc.? These sort of questions become quite complex when you have, really more than one trading counterparty, but especially as you have more than 10, as some of the consortia today do. The governance question becomes a big one, and just getting the understanding out there of what the benefits are and what the minimal changes to an enterprise's business process to see those benefits, which are considerable. Nevertheless, there's quite an education challenge in getting people to think that way.
And where do you see the Ethereum community overall in this space in the next couple of years?
That's an interesting question. Yeah. So the Ethereum community is, it's hard to put a label on it. I would say at the beginning, if you compare public Ethereum to public Bitcoin, public Ethereum community is sort of a little bit more positive, frankly. They're sort of less crypto-anarchist, a little more engineering-minded, embracing the change of the protocol, embracing, iteratively fixing problems where, Bitcoin has been locked in the same debates for 12, 18 months. So I think that's a big mentality difference. However, lots of the Ethereum community is sort of a shadow community in that many corporations use the technology but don't make too many public statements about it. And so the aggregate number of people who use the technology may actually reflect sort of a corporate mindset, though the loudest voices are, again, the public network advocates, if you will. So it's hard to exactly pin down who the Ethereum user is. But so the Enterprise Ethereum Alliance, of which BlockEps is a founding board member, and I personally sit on the technical working group, is kind of encompassing the corporate side of Ethereum. And we're well over 100 member companies. And so it'll be a vehicle for that voice to speak and have some future in the governance of both the public Ethereum protocol and kind of enterprise derivatives of it. So time will tell.
Exactly. All right. Also, a little bit of interest that I have seen from people now on the cryptocurrency space. Before we wrap up on the Ethereum aspect, is now around the altcoins, mostly around the fact that the price of Bitcoin and Ether has been going up. What would you say about the whole concept of altcoins, tokens? I've also been reading about ICOs, the initial coin offerings. How are they evolving, and why ICOs now?
Yeah, good question. So for the interested listener, I often look at coinmarketcap.com, which sort of has a listing of most or all of the altcoins. Basically, an altcoin is any blockchain currency besides Bitcoin. One could debate whether or not Ethereum counts as an altcoin. Usually altcoin means a Bitcoin derivative, but so at any given instant, you can see the market cap of all of the cryptocurrencies on coinmarketcap.com. And, it's a fluctuating number. There's a lot of excitement. Frankly, there are probably a fair number of speculators that are, moving those prices up and down at a given instant. And kind of reflective of the growth in the total market cap of cryptocurrency is the trend toward ICOs. And so what an ICO is an offering of tokens, often on top of the Ethereum protocol, actually, or otherwise. So in fact, people write smart contracts which take in the native Ethereum token, which is called Ether, and then can issue sort of sub-tokens, if you will. So that's one mechanism to create an altcoin. Yeah, and so the ICO world has become a vehicle to raise capital for certain types of corporations or even individuals that didn't exist before, and it's seemingly easier to get capital from an ICO perspective than, say, from traditional U.S. venture capital. And so it's an interesting phenomenon. They're happening all the time. Large amounts of money are moving in short periods of time. You'll see $15 million move in 30 minutes. And so it would be an interesting option for the less risk-averse startup founder to explore as a way to get capital. I would caution any of the listeners against an ICO, both from their sort of unclear legal territory and from a risk perspective. If you succeed and are ending up handling quite a lot of digital currency, that's a sort of heavy task from a security perspective. So it is nevertheless very interesting. I would say it's disrupting the traditional venture model, and we'll see sort of if the current wave of ICOs is to the degree to which it's a bubble or if it's a sustaining trend.
Interesting. The way the token market has just erupted, challenging a lot of existing mechanisms to raise money. It has been really good, Kieren, talking to you about various aspects of the blockchain world, starting from the history, the evolution, the crypto anarchist thought process that went in Bitcoin, and then how the industry itself has embraced and started looking at it from an enterprise software development perspective, and the different types of use cases that are coming up for blockchains to be used in. For developers, you actually gave a lot of context around how to develop smart contracts or look at Solidity as the language and various tools involved. I believe that there's a lot of follow-up on how these smart contracts can be used as a new development paradigm for writing transactions and developing on top of the Ethereum platform.
Hopefully, the listeners are excited about the technology, and we'll all go, download our developer edition at blockapps.net. And otherwise enjoy their days.
Awesome. Yeah. And where can people find more about you and reach out?
Myself personally, that's a good question, actually. I no longer have a personal blog. I do have a Twitter at K-James-Lubin, Jameslubin. You can also try to connect with me on LinkedIn, Kieren, Kieren, James Lubin.
Sure. I'll remember to put that link on the notes. Thanks so much for joining us today, Kieren.
Thanks, Kishore.
This is Kishore Bhatia for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.